Hey, third hour, totally missing you today. I'm at my math conference, having a good old time there. We're going to talk about functions in your notes. So first, let's start with some vocabulary, filling in the blanks in your note sheet. A function consists of a set called the domain, which contains the numbers called inputs. Sometimes we call that the set of all x's. And there's a set called the range containing numbers called outputs, and we call those the y's. Okay, so just to be clear, the inputs are usually the x's, and the outputs are usually, that's not a good y, are usually the y's. A pairing of inputs with outputs such that each input is paired with exactly one output is the definition of a function. So we have an input-output table showing the cost of various amounts of gas from the same pump. We want to identify the domain and range of the function. Well, our inputs are the gallons, okay? So these numbers here are going to be what we call the domain, okay? Those are the inputs. We put the gallons in. Okay, so for the domain, and I usually use this squiggly bracket. That's not a very good one, but that's what I do. I use the squiggly bracket to show that it's a set, and then I just put those numbers into the set. Now, if you ever have the same number occurring more than once, you only need to write that number once in the set of brackets, okay? Then our outputs are the range, okay? And the output for this problem is going to be the dollars, okay? Because that's what comes out. You have to pay the money. So we've got 19.99, 23.99, 25.99, and 33.98, okay? So that's the set of all outputs, the range. A function may also be represented by what we call a mapping diagram. Notice that an output may be paired with more than one input, but no input is paired with more than one output. Now, a mapping diagram could have an input being paired with more than one output, but in order for it to be a function, each input has to go to exactly one output, okay? 1 is only going to 0. 2 is only going with 1. 3 is only going with 2. 4 is only going with 2. Now, if you look at these next two, we want to tell whether it's a function or not. If I look at this first one, this is actually not a function. Okay, so I'm going to write that out first. This is not a function. And the reason why it's not a function is if you go back to the definition of function, it says that each input has to have exactly one output. But this 0 is going to two different outputs. So this right here is what is telling us that we do not have a function because 0 has two outputs. Each input can only have one output. If you move over to the next one, this mapping diagram is written out a little bit differently, but if you notice the 0, when 0 is an input, it's only going to 0. There's no other zeros in this column, which means that the 0 is fine. There's only 1, 1. There's only 1, 4. There's only 1, 6, okay? And each of those 4 numbers are specifically going to one output. So this one is a function, okay? Each input can only have one output. We're going to continue moving on in your notes, representing functions as graphs, okay? Filling in some more blanks, you can use a graph to represent a function. Given a table that represents a function, each corresponding pair of input and output values forms an ordered pair of numbers that can be plotted as a point. The x-coordinate is the input and the y-coordinate is the output. So we want to graph this function. We've got y equals 1/2 x plus 3. this is actually the function, okay? Now it's telling us to use this very specific domain, okay? We're only going to use these as our inputs. And remember, inputs are the x's. So I'm going to start with 0 for the x. And then to do the work, that just means I'm plugging it in. So it's going to be 1/2 times 0 plus 3. Now you can do a lot of this work in your head. If you need to work it out further, you can go ahead and write it down. 1/2 times 0 is 0 plus 3. 0 plus 3 is 3. So that is one of the points. Okay, so I'm going to go to the point 0, 3. And that is one of the points, one of the ordered pairs for this function. Now I'm going to go to the next domain, that's 2. Okay, and we plug 2 in. Y equals 1/2 times 2 plus 3. Okay, I'm going to work this out in my head. 1/2 times 2 is 1. 1 plus 3 is 4. So I should have a point at 2, 4. Okay, the next domain is 4, so I'm going to plug 4 in. So I'm going to have y equals 1/2 times 4 plus 3. Again, 1/2 times 4 is 2, or half of 4 is 2, plus 3 is 5. So I should have a point at 4, 5. 2, 3, 4, 5. Now we're going to plug in 6. Y equals 1/2 times 6 plus 3. Half of 6 is 3. 3 plus 3 is 6. So I have a point at 6, 6. So go ahead and plot that point. Okay? And then the last domain is 8. So I've got y equals 1/2 times 8 plus 3. Half of 8 is 4. 4 plus 3 is 7. So I should have a point at 8, 7. Okay? And the cool thing is, anytime you have an equation like this, y equals something x plus or minus something out here, or basically whenever you have a y and an x, it really should go in a straight line. And if you look at these points, they are going in a perfectly straight line. But we only want to graph those points. We don't want to draw any lines connecting them because it says that our domain is only 0, 2, 4, 6, 8. So I can't have any other lines or points at any other domain numbers. So this would be the final graph for that function. All right, this next one, our function is y equals -3/4 x plus 6, okay? And we're going to use these numbers for our domain. So first I'm going to start by plugging in -8. So y equals -3/4 times -8 plus 6, okay? And if you need to, you can always write out these fractions to work out. Remember, -8 is like -8/1. Okay, so I just wrote this out. And I'm only going to do that just this once, so you have an example of how this works. Remember, you can go diagonally to simplify. 4 goes into 4 once. 4 goes into 8 twice. Now if I multiply straight across, -3 times -2 is +6. And it would be over 1, so it would just be 6. So this right here is 6, plus another 6 is 12. Now our graph, this is going to go off the graph a little bit, but that's okay. We'll make this work because this goes up to 10, then we go 11, 12, so it's going to be right about in here would be our first point at -8, 12. Now I'm going to plug in -4, so y equals -3/4 times -4 plus 6, okay? -3/4 times -4, think about it, the 4s would factor out, so I'd end up with 2 negatives make a positive. +3 plus 6 is 9. So I have a point at -4, 9. Next up we have 0. So y equals negative 3/4 times 0 plus 6. Anytime you have something times 0, it's 0. 0 plus 6 is 6. So we should have a point at 0, 6. Go ahead and graph that. Plug in 4. Y equals negative 3/4 times 4 plus 6. Again, the 4's would factor out, but this time I'd have negative 3 plus 6 is 3. So we have a point at 4, 3. And then the last one, plugging in positive 8, y equals negative 3/4 times positive 8 plus 6. Okay? And if you do this multiplication, it's going to end up being negative 6 plus 6 is 0. So we should have a point at 8, 0. Okay? And again, these dots are going in a straight line because it's y equals something x plus 6. Okay? So we've got a nice straight line. And we've only got the dots because we're only working with those 5 domain numbers. This next function is y equals negative 2x plus 3. My first domain number is negative 3. So I've got y equals negative 2 times negative 3 plus 3. Negative 2 times negative 3 is 6 plus 3 is 9. So I should have a dot at negative 3, 9. There's my first ordered pair. Now the next domain is negative 1. So y equals negative 2 times negative 1 plus 3. 2 plus 3 is 5. So I should have a dot at negative 1, 5. There's my next ordered pair. Plug in 0. Y equals negative 2 times 0 plus 3. 0 plus 3 is 3. So 0, 3 is my next point. Then we have 1. Y equals negative 2 times 1 plus 3. Negative 2 plus 3 is 1. So I have a point at 1, 1. And then my last domain is 3. Y equals negative 2 times 3 plus 3. Negative 6 plus 3 is negative 3. So I have my last point at 3, negative 3. And again, this should be a straight line. Notice there's a little bit of area in here where it's kind of skipped, but it's still a nice straight line. But I'm only using those domains that they gave me. And that concludes what you need to do in your notes today. So if you could, please work on, in your books, page 38, numbers 1 and 3 through 10, and then page 46, numbers 1 through 9 odd. Have a good day.